Namaste everyone. Hope you are not bored with the current electricity. It is a very long chapter, but you can expect more questions from this. So that's why we will go slowly, because you have long days to go for the examination. You can go little by little, and also you have English examination. So we have been discussing about all these things in the current electricity. Shall we go to the next question? So we will move on to the next question. That is, so it's a very easy question. We were discussing about resistivity in the previous class. The ratio of resistivity of copper rods whose areas are in the ratio 1:2 and the length are in the ratio 2:1. They are asking you the resistivity ratio, not the resistance ratio. Resistivity of two materials, two copper rods, should be same. Suppose you have purchased 5 kgs of tomato, and your friend has purchased 10 kgs of tomato. Both of you are carrying tomato, and your third friend approaches you, both of you, and he asks both of you, what is the rate of tomato? Rate of tomato is same, and it is not the total amount of money that you have paid for all the tomato that you have purchased. So it is a rate per kg. So per unit length, per unit area of cross section, whatever be the length, whatever be the area of cross section, it is 1:1. Resistivity does not depend on length and area. It depends only on the material. Both are copper rods, so no problem. We will move on to the next question. Next question is here. Yeah. See, this is a very standard question, and of course, sometimes you need to work it out in advance before going to the examination. Then only you will do that. So sometimes the mind will not work at the examination hall. But still, integration and differentiations play an important role in solving many problems. So here is a problem. Figure shows a cylindrical conductor of length L and radius of circular cross section varies linearly from A to B. That means it is a uniform change of that radius as you move from A to B. So as you move from A to B, here to here, the area of cross section is increasing. Resistivity of the material is rho. So it is throughout, everywhere. Suppose this is the copper rod. Even if you cut it here, it is a copper. Here, if you cut it, it is copper. So resistivity is rho. It doesn't change. Assuming that B minus A is much lesser than L, so that you can neglect it, the change is very small compared to the length of the rod, then resistance of the conductor is. So we have conductor, just see the question and then see the options, how they are, rho L by pi and something like that. Because we will come back to the problem after a little bit, because this needs some explanations. So a conductor of radius A here, B little more than that, L is the length of the rod, and you have to find out the resistance. Resistance cannot be written as R equal to rho L by A all of a sudden, because all at once you can't jump into that formula, because A is not constant throughout, area keeps on changing. So how to solve this type of problem? Coming back here. So I will draw the diagram. You can also note it down. It will be like this. So you have a conductor of non-uniform cross-sectional area like this, and it is changing as you move from one end to the other end. Total length of the rod is like this, L, and this is the axis, and here is A, and here is B. Of course, remember, after solving this problem, don't get afraid of, because all the problems won't be like this. Right, now how to write? So our common resistance formula is R is equal to rho L by A. A is the area of cross section. You know which area you have to take, the area that you get perpendicular when the current flows. R is equal to rho L by A. Right, now how to change this area, because area varies as you move from one end to other end. So you have to go for integration, because the resistance of each piece here, suppose if I consider a small piece of the material at a distance x from one end, I will consider a small piece of the material at a distance x, and let the dx be the thickness of this small piece. So imagine a small cylindrical or chip shaped piece of thickness dx, and that is situated at a distance x from one end. What is the resistance of this? First of all, we will calculate. And if you want to know the resistance of this, you know the thickness of this. Resistivity of this is rho. The length of this is, so it will be like this. It will be a small piece like this.
So you know what is the length of this, that is thickness dx itself. So length, because length is the length along which the current moves like this. So this is dx. This part you know, this you know. Area of cross section, if you want to know, you must know the radius of this. What is the radius? Then you can write as a cylindrical, it is a circular face now, it is pi r square. But what r? It is neither a nor b, somewhat in between a and b. Now let me continue this here. I'll do it like this. Okay, I will continue this here like this. So let this be a, okay, this is also a, and the extra this height, what is that? That is what you have to find out, and it is given in the problem that it varies linearly. The thickness goes on increasing linearly. Since it varies linearly, it is a linear variation. Now when you move from this end to that end, that is when you move through a distance of L, you get a change in the radius as b minus a. Am I right? So when you move through a distance x, what is the change in the radius from a to what value? That is what you have to do. Did you get that? Because see where we are now, we are trying to get a, because we are trapped here now. If you get the area value, then you can write what the resistance of the small piece of the whole material is. Once you get the resistance of the small piece of material, you can integrate it from left and a to right and b, from here to here, and then you can continue it. Now, but in order to do that, now here, we have taken this small piece. Okay, right. What is the radius of this? That is our question now. We have stopped it at that point. In order to find out the radius of this, when you move through a distance L, the change in the radius is b minus a. So this extra value, this is b minus a, correct? So increase is b minus a. When you move through a distance x, what is the change? So what is this? That is this one. So when you move through a distance L, the increase is b minus a, this one. When you move through a distance x, what is the increase? So that will be b minus a into x. So that is this extra increase. What is the radius of the small piece? Then the radius of that small piece is equal to, radius equal to, I can write it as a plus this increase. Increase is this one, b minus a into x by L, correct? So when you move through a distance L, the increase in the radius is b minus a. When you move through a distance x, what is the increase in the radius? But total radius is that increase, this one, plus already this radius a. So we have got the radius of this. Now shall we write what is the resistance of this small material or small piece? Resistance of the small piece R is equal to rho L is a thickness, this one. I am concentrating only on this small piece. L is a dx by area. Area is pi r square. R square is this one. A plus b minus a by L into x whole square. So this is pi r square. Radius is total a plus this extra increase. Okay, so I have to write this as dr because it is the resistance of the small piece, this one. Then I have to get the total resistance of the full piece, and this is a general formula. Okay, now hope you are following. Right, now what is the total resistance? If you want to know total resistance of the whole material, if you want to find out, you can write it here. R is equal to the integration of this one, and x is starting from, this is in terms of dx, x is starting from 0 and x extending up to L, correct? X starts from 0 and x extends up to L, rho dx divided by pi into a plus b minus a by L into x, and that is whole square, pi r square. So this is the resistance, but this is a very peculiar equation and it is very difficult to integrate. So we will make a small logic here. Let us assume that this is a constant term.
Of course, x is not a constant, but these are all constants. So why can't I take let a plus b minus a by L, what the extra length that I have, this one, a plus b minus a by L into x, let it be equal to some z, some variable, because x is the only variable, all the other things are constants. Let it be taken as z. So this becomes pi z square. Now if this is z, differentiate this with respect to x. Let us make this equation very simpler. So differentiate this equation with respect to x and this with respect to z. So this is a constant, a is a constant, and b minus a by L is a constant, they do not change. So only x and z are variables. So if the differentiation of this is 0, what about the differentiation of this is? Suppose this is 6x, you will write 6. So b minus a by L, b minus a by L into dx, differentiation of x, is equal to dz. This is the differentiated value. Now suppose I want to substitute this as z, I have to change dx also. Variable also has to be changed. So what is dx? This implies dx is equal to dz divided by b minus a by L. Am I right? Anywhere I have gone? No. So dz divided by b minus a by L. So shall we substitute in this this as z square and this as dz? And of course when we take this as z, the integration limits will also get changed, right? Because if you substitute, so when integration limit starts from 0, x equal to 0 to x equal to L, what happens to this? When you take this term as z, when x is 0, z is 0, isn't it? No, when x is 0, z is a. So z equal to a, one limit, and what about here? Z equal to, when x equal to L, if you put L here, L by L gets cancelled, then what will you get? A plus b minus a, so you will get b. So z equal to b. So you have to change the limits from z equal to a to z equal to b, from x equal to 0 to x equal to L. Hope you have followed. So when you take the whole term, this one as z, this is equal to z. So the initial integration limits were starting taking such small pieces starting from x equal to 0 up to x equal to L. So put x equal to 0, then a becomes equal to z, z equal to a. Put x equal to L, this L gets cancelled, a plus b minus a gets cancelled, so z equal to b. So what will be the new term, new equation for integration? So the total resistance is integration from z equal to a to z equal to b. So what will be the term remaining? Rho by pi z square, am I right? This is pi z square, because the whole thing is taken as z, pi z square, and dx, instead of dx you have to write dz divided by b minus a by L. So shall I write that b minus a by L here? By L, this L goes to the numerator, so b minus a. Now it becomes easy for the integration, because it is only z which is variable, and rho, L, b minus a, pi, everything, every term is a constant. So it is that implies R is equal to rho L divided by pi z square, pi into b minus a, integration from z equal to a to z is equal to b, z to the power minus 2 dz. Am I right? Okay, I'll write it here. Z to the power minus 2 dz. Rho here, L here, pi and b minus a. Z I will take, z square I will take numerator to the numerator. Z to the power minus 2 dz. And you know the integration. Now only the mathematical part. R is equal to rho L by pi into b minus a. Am I right? Then here, so after integration, z is equal to a, z is equal to b. This is z to the power minus 2 plus 1 minus 1 divided and minus 1. Z to the power minus 2 plus 1 by minus 2 plus 1. So that is equal to, that implies R is equal to rho L by pi into b minus a. This is
minus 1 by z, right? Minus 1 by z. Z to the power minus 1 can be taken to the numerator. It becomes z to the power plus 1. And minus remains as it is, and limits are z is equal to a to z equal to b. Okay? Now, suppose I put the limits. R is equal to rho L by pi into b minus a. Suppose if I put the limits, z is equal to b, upper limit minus 1 by b, minus lower limit z equal to a, minus of minus 1 by a. So this minus upper limit minus lower limit, but lower limit is a. This itself is minus 1 by z, so minus 1 by a. So what will be this answer? Rho L into by pi into b minus a into, so this becomes 1 by a plus minus 1 by b, 1 by a minus 1 by b. So now you can take the common denominator. R is equal to rho L by pi into b minus a into ab is the common denominator, and here is b minus a. This term, b minus a gets cancelled. Rho L by pi ab, that is the final answer. Rho L by pi ab. Do you have that option? So that you have to search. If you go back to the problem, this is the way of solving, and 50% of it is mathematics, and only you have here in the beginning you have some glitches. You can rewind the video back and you can see that again and again. So we have that formula, rho L by pi ab. That is the fourth option. That is the correct one. Okay, you need some guidance in the beginning to solve these type of problems, but once you take such a type of different integration problems, then you will come to know how to solve them. Okay, so you have to take, this whole procedure is like this. You have to take a small piece here, find out its resistance, but when you find out its resistance, you want to calculate rho L by a, but a is the problem, pi r square. So radius has to be taken linearly in linear connection with a and b. That you have to do, and then you have to integrate it by suitable substitutions or so. So answer is fourth option, rho L by pi ab. So we will move on to the next one. Okay, yeah. When a 5 volt potential difference is applied across a wire of length 0.1 meter, the drift speed of electrons is 2.5 into 10 to the power minus 4 meters per second. If the electron density of the wire, if the electron density in the wire, that is free electron density, is 8 into 10 to the power 28 per meter cube, resistivity of the material of the wire is close to. See, such type of problem, even it is asked for JEE main, it's not a very tough problem, and you can solve it. It is it is very close to the theory what we have studied, and it is not out of syllabus, or it is not very tough. You just remind all the formulas that you have studied related to current, drift velocity. You see V equal to IR, very important relation, and R is equal to rho L by A, you know this. And we have I, current I is equal to NEAVD, right? So we have all these equations. And if you just go back to the problem again, I equal to NEAVD, does this equation work? The problem, if you go back to the problem, does this equation work here? Definitely, because number of free electrons per unit volume is given, charge of the electron, you know, area, of course it is not given, but we have to see somehow, we have to get it. Drift velocity is given, but their question is rho, right? What is the resistivity? So shall we get rho in this equation? We will try to get resistivity in this equation. Current helps us because V equal to IR, R contains rho, so we will mix it up. What is I equal to? I equal to V by R. Voltage by resistance, that is equal to NEAVD. Now that implies, what is R is equal to? Rho L by A. So V, potential difference, by rho L by A. I will expand this one. Then here I have expanded I equal to V by R. Here I am expanding R, rho L by A, is equal to NEAVD. You see, area gets cancelled. So that was the problem when just a few minutes back, what to do with the area. Area doesn't come into picture here at all. Now what else is needed? Everything is available. V is available, L is available, everything. You have to find out rho. So shall we rearrange the equation for rho? Rho resistivity is equal to, you can bring rho here and everything else here. V divided by NEVD, A has cancelled, L. Am I right? Simple substitution, enough. You see how easy it is. Only the thing is, you have to prepare a chow chow bath out of all the equations that you have in your textbook. That's all. You have to get connected with all the equations, because we don't have any relation for resistivity and drift velocity. But drift velocity and current we have. Current and resistivity we have in terms of resistance. Okay, so what is V? V is 5. Only substitution now. N, number of electrons per meter cube, 8 into 10 to the power 28. Okay, into charge of electron 1.6 into 10 to the power minus 19 coulombs, into drift velocity. What is the drift velocity given? Drift velocity is 2.5 into 10 to the power minus 4. You see how slow it is. Electrons are very slow, moving very slowly inside metals, because they will collide and lose the energy. Velocity is very less, 2.5 into 10 to the power minus 4. Length of the conductor is 0.1. Okay. Now, so this big number, do we want calculator? No calculators, please. You can do this. How? You see, shall we have, you see this number? This is very easy. 8 2s are 16. 2.5 we have here. What is half of 8? 4. So 8 2s are 16 plus 4, 20. So 2.5 of 8 is 20. Right? 8 2s are 16, and you have still 0.5. 0.5 of 8 is 4. So 16 plus 4, 20. 20 into 1.6. 2 into 1.6 is 3.2. 20 into 1.6 is 32. Over. So rho is equal to 5 divided by 32. 8 into 2.5, 20. 20 into 1.6, 32. Into 10 to the power. So these three things are over. Minus 1, minus 5. 10 to the power minus 1, this one. 10 to the power minus 5. 10 to the power minus 24 totally, right? 10 to the power minus 19, minus 23, minus 24. And here you have 10 to the power 28. So what is actually remaining finally? 10 to the power minus, plus 4, 28 minus 4. Now, this is, okay, 5 by 32. I will go very close to this. So 6 is enough for me, because you see the answers, all the answers are 1.6, so need not worry about the exact one. So 5, 6 times. What is this one? 1 by 6 is 0.1 times 10 and, for 4 remaining, 40, 1 times 6, 40 remaining, so 6 times into 10 to the power minus 4. So which answer suits for this one? 0.166 you don't have. You have all 1.66s. So 1.66 into 10 to the power minus 5. So answer is fourth option. If you go to the problem, it's the fourth option which suits for this one, right? So easy problem actually compared to the JE level. This is very easy problem. So you will have these types of problems also, and the previous one also. So you can expect all types of questions. But you shouldn't leave any easy problem as it is. You must crack it, and you should get the answers. Okay, shall we move? We will move on to the next one. Yes. Again, within your syllabus, right? It is not away from your syllabus. Yeah. Potential difference is applied across a conductor of non-uniform cross-sectional area, A1 greater than A2. So it is like a pipe in which water flows. And A1 is more, A2 is less. We have to apply a battery across A1 and A2. If I is the current and J is the current density and Vd is the drift velocity, then select the correct option. Read the problem, see what are the options. From where will you start? Which equation will you take for reference? See that? You have been given a non-uniform cross-sectional area conductor, and you have been asked which is constant in this, which is variable, which is greater than what quantity. That is your job. Okay? Yeah, coming back to the problem now. So here is a cross-sectional area more, and here is cross-sectional area less. Of course, electrons should move like this, right? There is no way. Now, A1 is greater than A2. Now, this is very similar to different resistors in series, isn't it? You divide this into different parts like this. Will you get small coin-like arrangements? And will they have different resistances here, right? Resistance of this, everything will be same. Different. Because their area of cross-sections keeps on changing. Now, is it not like different resistors in series? Whatever be the amount of resistance, when you connect them in series, definitely what is same? Definitely, current is same. So, either you can go for second option or, okay, you need not go to the question now. There is a second option and fourth option. I1 equal to I2. Only two options carry I1 equal to I2. Other options, I1 greater than I2, I1 less than I2 and so on. So, I1 must be equal to I2. If current entering is I1 and current leaving is I2, that must be same, because in series, so I can write this as equivalent to a number of resistors connected in series like this. Each slice as a resistance. So, in series current should be same. If these two have to be same, you know that current density, see what are the factors they have asked? Current density, drift velocity and current. These three are compared. Very easy comparison. J is equal to I by A, right? Once I is constant, current density is current per unit area. Once I is constant, J is inversely proportional to A. So, if A1 is greater than A2, definitely J1 is less than J2. Current densities are inversely proportional to area of cross section since current is same. Okay, so two answers we have got. Now what about drift velocity? If you want to know, NEAVD1 is equal to NEAVD2. Okay, A1, A2. Current in the left hand side is NEA1 VD1. NEA2 VD2. Sir, why didn't you take suffixes here? Very simple. This, if you take, suppose this is a copper rod. If you take one piece from here, what the electron density you have, same electron density should be here, because both are copper pieces. So, N should be same. And the electrons which are flowing on the left hand and right hand are same. They have the same charges. So, E is a constant. So, A1 VD1 must be equal to A2 VD2. That is, A1 by A2 must be equal to VD2 by VD1. What does this mean? That is, area of cross section is inversely proportional to drift velocity. This looks very similar to that equation of continuity that you get in first year in fluid flow. If more the area, lesser will be the velocity flow. That is like blood flow in blood vessels. More the area of blood vessel and slower will be the blood flowing, and as the cholesterol get deposited, the area of orifice goes on decreasing, and finally the speed goes on increasing, and that makes the pressure to collapse and the different results, okay, whatever it is, right? We will take the physics part of this. Area is inversely proportional to drift velocity, right? Now, if it is so, how can you write this one? So, area 1 is greater than area 2, but J is inversely proportional to A, so J1 is less than J2, and again drift velocity is inversely proportional to area, so VD1 is less than VD2. Now going back to the problem. So, only A1 is greater than A2, and okay, I1 equal to I2, yes, I1 is equal to I2. So, I1 is equal to I2, J1 less than J2 and VD1 less than VD2. We are going back to the problem now. So, which option will give you the answer? Is it the fourth option, right? Current same and opposite, or in the opposite way of area you should have current density and drift velocity. Is it the one? Fourth option, correct? Option number 4. Okay, shall we move on? So, very good problem. The only thing is you have to just think of with what the formulas you have. Okay. This is the same problem, similar type of problem. Across a metallic conductor of non-uniform cross-sectional area, a constant potential difference is applied. Okay, I will connect a battery, DC battery, across a conductor of non-uniform cross-sectional area. Same diagram, previous one. The quantity which remains constant along the conductor is, definitely it is current. It is none other than current. Current remains constant. So, it is
always constant throughout the material. Okay, option number 2. Okay, see how easy it is. It is asked for NEET 2015, right? So easy questions may also be asked, right? Now we will move on to this question. A potential difference of 10 volt is applied across a conductor of length 40 centimeters. Mobility of electrons if the drift velocity is so much is. See the quantities which you have to connect it. We will keep in the problem itself. Potential difference of 10 volt is applied across a conductor of length for 40 centimeters. So V is given, potential difference, length is given, mobility of electrons is asked, drift velocity is given. What is the mobility? Now we know that, suppose coming back to the board, if you have a conductor, right? Suppose you have a conductor of length L, like this. When you pass current through the conductor, how do you define mobility? Mobility of any charge carrier is the drift velocity per unit electric field. What is the mobility of a sports person? How fast he can run in a certain situation. Situation is electric field. How much electric field you have applied. Okay, drift velocity applied per unit electric field is mobility. Now the data, I will list the data, you need not go back to the problem. Potential difference applied across the conductor is given, V. Okay, I will write the formula here. Mobility is drift velocity acquired per unit electric field. So potential difference applied is given to be 10 volt, and you just message to me. I will give you the PDF form of this question paper, so that if it is with you, you can use it, right? That is better. If you have that PDF form in another mobile or so, it becomes easier. 94801 98001. You just message to that. I will send you the question paper, or you can collect it from your friends. Okay, suppose this is 10 volt, and what else is given? 40 centimeter. Length is 40 centimeter. Okay, what else? Mobility of the electron, drift velocity is given. If the drift velocity is 5 into 10 to the power minus 6 meters per second is, what is the mobility? If it is this much, what is the mobility? Now, you have been given VD, but you have been given E. Now, do you have any electric field relation which can be obtained using this and this? Which can be used to obtain the relation between the value of electric field E? Yes, possible, because electric field E is nothing but potential gradient. You know delta V by delta L. We derived this in potential chapter. So, if you want to know what is mobility, mobility is the question, and drift velocity divided by electric field, which is nothing but delta. Okay, we can write it as V by L, since it is uniform everywhere. This is potential difference V, this is the velocity, drift velocity. Okay, substitute. Mobility mu is equal to drift velocity 5 into 10 to the power minus 6. Length of the conductor is 40 centimeters, 0.4 meters, divided by potential difference applied 10 volt. So what may be the answer? 5.4s are 2. So I will finish these two. 5.4s are 2. 10 to the power minus 7 totally. Minus 1 by the time it comes to the numerator, and minus 6. So this is the drift velocity, right? You can see the answer. It is 20 to 10 to the power minus 7. 2 into 10 to the power minus 7. Yes, we have the answer. You can go back to the problem. It is option number 4, I think. 2. It is second option, right? So it is 2 here. 2 into 10 to the power minus 7. Now going to the next question, right? So it's a direct one here. Okay. Yeah, we have studied. We can quickly go through some of the problems here. Yesterday, in the previous class, we have spent so much of time in stretching a wire, compressing a wire, percentage change and all. Now we see. A wire of length L is redrawn to a length 2L. What do you mean by that? You have to take a wire and you have to stretch it. When you stretch it, the length gets doubled. Then its resistance will be. You know this. Resistance of any wire when it is stretched n times is n square L. Here n is 2, n square is 4. So it increases to 4 times, increases by 3 times,
and increases by 300%. You know this. So in the previous class we have been doing this very rigorously. So when the length is double, the n is 2 square, so n square is 2 square, so the new resistance is 2 square times the old resistance, it is 4 times, increases to 4 times. Okay, next question we will move. So we can do this now very fast. Yeah, a wire of resistance R is uniformly stretched until its radius is halved. When the radius is halved, it is by n to the power 4. You know that resistance is okay, we will discuss this now. Coming back to the board, resistance is equal to rho L by A, but is equal to rho L by pi R squared, right? When you stretch it, this again increases n square times. So if your wire is stretched such that radius is halved, then what happens is when radius is halved, the new resistance is radius to the n times. How many times it is how many times it is stretched so that radius becomes n times the new old resistance. So that is equal to, so old resistance by n to the power 4. Now it is old resistance by n to the power 4 means the radius is halved, 1 by 2 to the power 4. This is 2 to the power 4, that is 16. New resistance is 16 times the old resistance. Whereas when it is stretched so that length is doubled, tripled, made 5 times, then R dash is equal to simply n squared R. When its length is increased 2 times or 3 times. But when its radius is increased when the radius becomes 1 by 2 times, 1 by 3 times, then you have to put n to the power 4 here. Okay, 16R, you have the option, second option. Going back to the question, it is second option, 16R. Yesterday we discussed this part. Okay, then this part also we have stretched this wire. A wire is stretched by 2% in length, then the percentage increase in the resistance will be. Here we have not discussed 2%, we have discussed 20%, 10%, and so on. So in general, the discussion is like this. Suppose R dash is the new resistance, and so it is a new resistance, and R is the original resistance before stretching. So wire is stretched when its resistance was R. After stretching, its resistance is R dash. Suppose it is stretched such that length increases by n times, then new resistance is n square R times. Suppose it is stretched such that radius is n times, n means here fraction, half, 1 by 3 and so. If it is stretched, of course, the radius should get decreased, so it is a ratio. Radius is n times the original radius, then resistance, new resistance is old resistance by n to the power 4, because already it is pi r square. Then when it is stretched, it becomes n to the power 4. So yesterday we discussed this. Now coming back to this here, what is the problem? A wire is stretched by 2%. You know R dash is n square R. If a wire is stretched by 20%, what you will write here? If it is stretched by 20%, by 20% means you have original value 1, 20% extra. If it is 100, 120. If it is 10, it is 12. If it is 1, it is 1.2. So what is the new resistance? 1.2 square R, original resistance. So R dash is equal to 1.44 R, 1.2 whole square. So 44% extra. That is for 20% raise in length. 20% increase in L results in 44% increase in resistance. But now the question is not 20%, it is only 2%. So I have forgotten to discuss it in the previous class. What about 2%, 1%? Of course, you will do that yourself. If it is 1%, sir, L increases by 20%. How do you write it? L becomes 1.2 L. Am I right? L increases by 30%. L increases by 30%. How do you write it? Here, L should be written as 1.3 L. L increases by 50%. That means out of 1 L, you should have 50% extra. 50% extra means 1.5 L. So these are all the conditions. Now L increases by 1%. Here the question is 2%. We will see all the percentage. Now L increases by 1%. How do you take 1%? If it is 10%, of course, L becomes 1.1 L. 100 becomes 110. 1 becomes 1.1. L increases by 1%. How do you write it? To 1, you have to add 1%. That is 1.01. Am I right? L becomes 1.01 L. Am I right? So if the length of the wire increases by 1% after stretching, what is the increase in the resistance in the percentage? That is the question now. Of course, these problems give you lot of ideas. And if you get the similar type of equation in some other chapter, of course, the method is the same. Same procedure, same mathematics, only the concept is different. Now, if the length increases by 1%, 1% is 1 out of 100, increase it by that much, then it is 1.01 L. So now, N has to be substituted as, new resistance is N square times the old resistance. N square is 1.01 square R, and this is a ready-made formula. After substituting all the lengths, we got this formula. You see the previous video. 1.01 square R. You know what is 1.01 square? 101 into 101. 101. 0, 0, 0, 1, 0, 1. This is 1, 0, 2, 0, 1. So what is the answer here? R dash is equal to 1, 0, 2, 0, 1 R, but here there are 2 zeros. So you should have 4 here. 1, 2, 3, 4. It is 1.0201. R dash is 1.0201 R. Now how much percentage wise this is more? Multiply. So here you have 1 R. In the beginning you have R. Original resistance is R. Now you have the resistance which is 1.0201 R. Multiply this by 100. Won't you get 102 here if you multiply it by 100? 102.01. 0.01 we will leave it off. So how much percentage it is more? So R increases by 2%. Am I right? So if the length increases by 1%, resistance increases by 2%. Now we will come back to the question. What is the question? Length increases by, a wire is stretched such that L increases by 2%. What is the percentage increase in the resistance? Now, how do you represent 2% increase? If L is the original length, then new length will be L plus 2% of L. Increase it by 2% of L. This is 1.02 L. So what is R dash? R dash is, so you must be able to do this mentally. I am writing it now, but without writing you can do this when you solve many problems. For example, if I ask you length increases by 30%, what is the percentage increase in the resistance? You know that it is 69%, because 30% leads to 1.3 whole square. 1.3 whole square becomes 1.69, so you have 0.69 extra. So similarly this one also. Next time you should not be in a position to do this again. You should be knowing it already. So the new resistance is 1.02 whole square R. What is 102 into 102? Okay, multiply 2 2s are 402, and this is 0 0 0. This is a 1. Okay, here 2 0 1. 4 0 4 0 1. So answer is R dash is equal to 1.0404 R. So what does this mean? Multiply this by 100. 104.04, right? So what is the new resistance? It is 4% more, right?
resistance increases by 4%. So don't be under the impression that it is just multiplied by 2, because when length increases by 1%, resistance increases by 2%. When the length increases by 2%, resistance increases by 4%. This may not be the case always, not multiplication by 2. The procedure you must know. So coming to the question, it is the second option, 2%, 4%, right? When length increases by 2%, the percentage increase in the resistance is 4.04%. So it is this one, option number 3. Shall we move on to the next question? So, these are all very easy questions, because already you have been in practice with the current electricity from 3 hours or 4 hours. Now you are an expert, little bit expert in solving the problems. Here you say, a technician has only 2 resistance coils. He has only 2 resistors. By using them singly or in series or parallel. So either you connect both in series, both in parallel, or they use it in alone, one by one. He was able to obtain the resistances 3, 4, 12 and 16 ohms. What are the resistances? Suppose you have 2 resistances, R1 and R2. What are the ways in which you can use it? R1 only, R2 only, R1 plus R2, and another one is R1 R2 by R1 plus R2. In the theory, you know clearly that parallel combination gives least resistance. So this should be the parallel combination, 3 ohm, am I right? And series combination gives the most resistance. So this should be the series. So when they are connected in series, this should be the answer. When they are connected in parallel, this should be the answer. Then what are the resistors? 4 and 12. This must be the answer. What are the resistances? You need not calculate it at all. 4 and 12 should be the answer, because 4 plus 12, series 16. 4 into 12 divided by 4 plus 12, R1 R2 by R1 plus R2. Answer is 3. So 4 and 12 ohms are the resistance coils. Of course, you can work it out. You can do that, because the most and the least should be most one series, least one parallel. So 3 parallel, 16 series. Remaining 2 should be the resistors. So option is second one. Easy question. Okay, we will move on. Yes. Unequal resistances are first connected in series and then in parallel. What is the ratio of maximum to minimum resistance? Maximum when they are in series, minimum when they are in parallel. Okay. Read the problem, and if you want you can write it also, no problem. And if you have the PDF form, better not write it, just read the problem thoroughly. Try to see whether you can do anything in this problem, because in the examination you are solving it. So you must be able to do something with the problem now. Yeah, we have unequal resistors, and once they are connected in series and another time in parallel, what is the ratio of maximum to minimum resistance? Okay, coming back to the board, you know that when unequal resistors are connected in series, right? You know this, right? When unequal resistances are connected in series, NR, because if you have R in series, R plus R plus R plus R plus R, NR. When they are connected in parallel, unequal resistances, R by N, because suppose you have 3 resistors, 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R. That is 1 by Rp, that is equal to 3 by R. What is Rp? R by 3. So you can use R by N formula. So maximum to minimum resistance, what is the ratio? So I will write simply ratio R maximum to R minimum. Maximum is NR, R plus R plus R plus R plus R. Minimum R by N. So what is this? RR gets cancelled. It is N square. Correct? So option 2. Finished problem. It's a very easy problem. It is the second option. Option number 2, N square. Maximum to minimum. Maximum is NR. Minimum is R by N. RR gets cancelled. N comes N square. It becomes finally. Okay. Yeah. Again, an easier question. Right. Yeah. A uniform wire of resistance R and length L is cut into 4 parts, each of length L by 4, which are then connected in parallel. The effective resistance of the combination is. So shall we try to do this mentally without writing anything? you can do it like this. Resistance R, length L. You know that resistance is directly proportional to length. And if you cut the wire of length L into 2 equal parts, resistance also gets halved, because R is rho L by A, and when you cut the wire, rho remains same, A remains same. Only L is the factor which is changing. R is directly proportional to L. When L is L by 2, R is R by 2. Now it is cut into 4 equal parts. So what is the resistance of each part? R by 4. R by 4, R by 4, R by 4, R by 4. Because each length is L by 4, which are then connected in parallel. Then what is the effective resistance? Each R by 4, 4 such resistors in parallel. So what is the effective? R by 4 by 4, right? So when the wire, coming back to the board, when a wire of resistance R is cut into 4 equal parts, total resistance is R, it is equivalent of R by 4 in series. Now cut this in and connect them in parallel. Let they be connected in parallel like this. Okay? R by 4, R by 4, R by 4 and R by 4. So each one is R by 4. So what is the equivalent resistance? You know that R dash is equal to R each by N. Each R is R by 4 by N 4, R dash is R by 16. That is the answer. Do you have R by 16? Yes, that is second option. Second option, R by 16. Correct? Yes, this one. So first R by 4 each, then R by 4, R by 4, R by 4 parallel, R by 4 by 4, R by 16. Right. Then moving on to the next problem. Yeah. Resistances R1 and R2 have effective resistance Rs when connected in series, and Rp when connected in parallel. Okay, they are the symbols used. R1 R2 is 16, R1 by R2 is 4. Calculate the value of R1 and R2. Actually this problem, I don't know who designed this one. I picked it from somewhere else. You need not have any physics at all. You can do it like this. Search the options which give product 16, ratio 4. That's all. That's enough. Product 16 and ratio 4. I think calculate the values of R1 and R2. Product is 16 and ratio is 4. Product 16, ratio 4. Oh, you have two answers, right? 0.2, no, you have many answers here. Okay, we will work it out. Rp, we will work it out. R1, R2 is 16. We'll have to do that, I think. R1, R2 is 16 and R1 by R2 is 4. Okay, we will use this. That means, can you write R1 is equal to 4R2? One equation here. Yeah, remaining. Now parallel it is given. What is parallel? Rp and Rs. But parallel and, okay, R1 and R2 in. Calculate the values of R1 and R2. Okay, R1 by R2, 0.25 by 4. Or otherwise you can do one thing and you can use Rp and Rs formula. What is Rp? Okay, we will do that. Rp is equal to R1 R2 divided by R1 plus R2. Right? So you can do this. What is Rs? Rs is equal to R1 plus R2. Right. Now Rs should be, Rs and Rp values are not given. Okay. Right. What is Rp? Rp is not given, Rs is not given, and you have to find out, calculate the individual resistances. Okay. But each product, R1, R2, yeah, the first method itself is okay. Coming back to the question. No physics is needed. I didn't get that idea. R1, R2 product should be 16. I hope you have got the answer. I didn't get the idea. R1, R2 should be 16. Which gives the answer? Only this one, correct? No other option gives product equal to 16. Of course, I was searching this one. R1 by R2 equal 4. Many of the options give R1 by R2 equal 4. But product is given by only this one. Of course, ratio, this is 4. But no other option gives the product 16. So option 3. Need not work it out at all. It is option 3. Right. Let us move on to the this question. And 3 resistances, 2 ohm each, are connected to form a triangle. Resistance in ohms between any 2 corners. Yes. Shall we do this mentally? I don't want to do this because you have written the theory exam, you know what is the idea behind this. In a triangle, you have 3 resistances, 2 ohm, 2 ohm, 2 ohm. If you take base, for example, you will have 2 ohm at the base and 4 ohm at the top, because 2 ohm in series. So finally, what is the answer? 2 into 4, got it? Base 2 ohm, the upper 2, the sides of the triangle, 2 plus 2, 4. So 4 parallel 2, 4 into 2 by 4 plus 2, 8 by 6, 4 by 3. Do it yourself, option 4, 4 by 3. 4 parallel 2. And even 41, a carbon resistor has a color scheme as shown below. You will be disturbed by the sunshine. Okay, now it's correct. Carbon resistor has color scheme brown, black, green and gold. Its value is very easy. Brown, black, 1 is 1 0. Gold, green 10 to the power 5. 1 0 10 to the power 5. And gold plus or minus 5%. 1 0 10 to the power 5. 1 0 10 to the power 5 means 1 into 10 to the power 6 plus or minus 5%. Option 3. Third option. Okay, very easy problem. Right. Now, you will have a very beautiful class. I am going to have a PPT class with all the equivalent resistors. We will enjoy it later. After 2 or 3 classes, we will have having all types of combinations of resistances. How to do it quickly and how to get the answer. Of course, this is a very simple network where you have to get the equivalent resistance. I don't use the board, blackboard. I will use only the scale and the display. Now, in the circuit shown, every resistance is 24. 24 parallel 24. Is it 12? 24 by 2, R by N formula. 12, 24 by 3, it is 8. 24 by 4, 6. So 6, 8 and 12. What is the total resistance? 24 by 2, 12, 24 by 3, 8, 24 by 4, 6, 6, 8 and 12, it is 26 ohm, am I right? Fourth option. Option is 4. This is very easy, but we have some complicated, some networks whose equivalent can be found out very easily. Right. Shall we move on? Yes. See, this is a problem which we work out for theory exam also, but here options are given, so you can have a very easy answer. Effective resistance of 2 resistors connected in series is 16. When connected in parallel is 3. Here, since options are given, you can check the reverse order. You can check the options. See, for example, they are connected in series 16. Here you get 16. Here you don't get. Here you get 16. Out of these 2 options, 1 and 3 you have to select. When in parallel it is 3. Parallel combination 3 is only for this one, not this one. 15 into 1 divided by 15 plus 1 doesn't give you 3. This gives 12 into 4 by 12 plus 4. So option number 1. I think I am not moving fast because you are very good in all these things, even in the theory. But there is no sayings that these questions will not be asked in the entrance exam. You may get these types of also, but you should have all these basics also very clear. Okay, then 44th one. An effective resistance R is obtained by connecting unidentical resistances. Each of resistance are in series. When the resistances are connected in parallel, the effective resistance of the combination is. Of course, problem is easy, but selecting options requires little bit of work here. Now, what do they want here? An effective resistance of R is obtained by connecting n identical resistances, each of resistance small r in series. I will connect small r's in series, R, n times, and effective resistance is R, which is nothing but nr. So this is equation 1. Then, when the resistors are connected in parallel, the effective resistance of the combination is. So R effective in parallel is R by N, correct? Each resistance R
R are connected in parallel n times each of R. Now it is R by n. But answers, now they want what is the effective resistance when they are in parallel combination, that is Rp is needed. But there is no answer small r by n. In the options there is no option small r by n. So now try to incorporate this. Rp is equal to. Now let me write what is small r, because answers all contain capital R's. So shall I change this formula as, before writing Rp, as small r is equal to capital R by n. So shall we substitute this here? Small r is equal to capital R by n. Then what is Rp? Rp is equal to R by n, that is small r here, and by n, this n. This r is r by n. Then by n here. What is this one? R by n square. One answer. Do you have capital R by n square? No. You have n square by capital R. That is wrong. Okay, put it in other way. Is there any other possibility? Rp is equal. Substitute for n now. We will change this. So I can write this equation as, we will have to substitute for, we have substituted for small r, now let us substitute for small n. N is equal to r by r. If n is equal to r by r, what does Rp become? Rp is equal to r by small n. Small n is r by r. So what is this? R squared by capital R. Do we have this one, or anyone? We have small r squared by capital R. So option number 4. Going to the question now. So it is option number 4. But we don't have this option. This is also correct. So it is, this is also correct. This is also correct. But out of the option, this is inverted in the answer. So going to the question now, that is this one, last option, small r squared by capital R, right? And yes, 45. A uniform wire of 16 ohm is bent to form a circle. The effective resistance between the ends of the diameter of the circle. Now you see, you have to think of two things. When you have a circular wire and it is bent in the form of a circle, so you will have to take the effective value also. Simply if you cut it and it becomes half or so, resistance is directly proportional to length, that effect is also must be taken into account. And in addition, how they are connected. It is in the form of a coil. So if a 16 ohm resistance is bent into the form of a circle, then the effective resistance between the ends of the diameter. Coming back to board, you can solve it now. Very easy problem. When you connect a 16 ohm resistor in the form of a circle, half of the circle will have 8 ohm, remaining half will have 8 ohm, because totally it is 16. Since it is, and if you cut this wire and make it into a single length wire, and it's 16 ohm. So it is half 8 ohm and 8 ohm. Now, what is the resistance between two diametrically opposite corners? 8 parallel 8, 8 by 2, 4 ohm. Right? Answer is fourth option, 4 ohm. Resistance between two diametrically opposite corners is 4 ohm, because even though the total wire resistance is 16, when it is bent into the form of a circle, half circle will have 8 ohm resistance. So they are in parallel since they are in the form of circle. So it is 8 parallel 4, option 4. Yes. Yeah, effective resistance between A and B. Another that equivalent circuit. Just now I said that we are going to solve such types of circuits in many numbers because I need PPT for it. It becomes easier if I have PPT. We will do a PPT class, especially for equivalent resistance after 2 or 3 classes. Okay, now this one, you see, let me go back to the PPT, this one only. Now, here you see a wire. Always you shouldn't connect the two ends of the same wire or same resistance by a single wire. If you connect this by a wire, what the problem is? When the current enters through this part, it doesn't select this path at all, because this is a resistance path. It selects this path because this is the easiest path. When you have a mud road and a tarred road, which road will you select? Most of the vehicles will select the tarred road. Why should they select the mud road? No need. So no current flows through this. That means this is short. All the current flows through this. This resistance is not effective. It is as if connect a resistance 2 ohm and another 0 ohm in parallel. What is the effective resistance? Effective resistance is R into 0 by R plus 0. This is 0, this is R. R into 0 by R plus 0. 0 by R. Answer is 0. So you can remove those two resistances. So don't connect any two resistances directly by a wire. Of course, you can connect their one end and another end of another resistance by a wire, no problem. So coming back to board now. So there are resistances are like this, right? So this is 1 ohm and this is 1 ohm and these are all 2 ohms, 2 ohms and 2 ohms. Problem is this is shorted, 0 ohm. This is shorted and this can be connected directly here because everything is a short. It is as if you are connecting it here. It is as if you are connecting it here and here. So what is finally remaining? This 2 ohm, nothing will happen to this 2 ohm because the two ends of this 2 ohm are not connected by a single wire. It is safe. What about this? 1 plus 1, 2. That is in series. 2 parallel 2, that is 1 ohm. 2 by 2, R by N formula. R is 2 by N, 2 times. 2 by 2, 1 ohm. So option is fourth one. Fourth option it is. Very easy. So now if you look into the circuit, you will come to know why it is so. So this is shorted, this is shorted, this will remain parallel with this series 1 plus 1. Here you say, sir, is it not whether these two resistances are in short? No, never, because the two ends of the different resistors are connected by a wire. They are not been connected. This wire is not connected to a single resistor. So if a single resistor, two ends are connected by a wire, then the total resistance is 0. Okay, so we will end up here, and the next class we will go to multiple grouping of cells and power dissipated in a resistor, and then we will meet back. So we will go little by little slowly. Don't be in a hurry, but once you study these problems, you should be so firm with all the ideas and methods that you must be able to remember it till your examination, which are going to happen after a very long time, after many days, right? So keep going well. Let us meet after in the next class. Thank you.